speaker. That means good evening, China. Again, good morning, Brazil. And let us start right from the Thaisa Sala Michelin from Brazil. You now may start and launch your presentation. Hello.
Hello. Good morning. Are you see my presentation?
Please share the screen.
It's working now?
Not really.
Sorry. Oh.
Maybe wrong screen.
It's okay?
No, we're just seeing your folder.
Oh, just sorry.
No worries, no worries. I'm reminding everyone that today we're also having experiments that have been prepared by our chemists. Funny photochemical experiments, lots of fun, don't miss.
No, it's working? No?
My advisor is telling me that you should launch the presentation and then click the share screen button.
So we tried a few minutes ago and worked, sorry.
No problem. Still seeing your folder.
I don't know what's happened here.
All right, my advisors are telling me that maybe we should just move to the next speaker while you're just managing to work with the technicians.
Yes.
Would that be okay?
Thank you. Thank you, perfect.
No worries,
Sorry.
no worries. A little misinterpretation here. Okay, Maria Gordeeva, Russia.
Hello?
Hello, you now may launch your presentation.
Yes. Okay. Do you see the presentation?
No, we don't. I see the screen message.
And what do you see?
No, that you have launched the demonstration of the screen, but we don't see. Oh, here we go. Go ahead, 12 minutes.
Okay, hello Oleg once more again. Hello participants. I'm very glad to see you here. And I'm from Kazan State Power Engineering University, and work in like associate professor of water resources and aquaculture department. And I am a PhD in biological science. And my theme is integrated assessment of the state of water ecosystems. Let's start. Since ancient times, people have settled near water, which have played an important role in their lives. In this context, water resources should be emphasized as an essential element of economic development, taking into account their social and environmental benefits. Water pollution is currently one of the major environmental problems of urbanized areas, as stated in a decision of the 8th World Water Forum. The quality of water and feed inputs in conditions of industrially developed regions with a high degree of anthropogenic impact on the territory become especially significant factors. This fact is connected not only with the increase of population, but also with the fact that preference is increasingly given to healthy food. According to FAO data, mankind annually consumes 90 million tons of products produced by aquatic ecosystems, including 30 million tons of aquaculture. In the 21st century, 130 million tons will be needed to address the nutritional needs of the growing population. However, fishing can't continue to address the growing demand for fish. And its catch has reached a relatively stable limit since the mid-19th and amounts to approximately 59-90 million tons, but not more than 100 million tons per year. This calls for the active development of artificial systems for cultivation of hydrobionts, where controlled water quality is particularly relevant to for the successful cultivation of valuable fish species. Artificial systems, I mean water closet supply systems. The normative documents of the Russian Federation
Yeah, Maria, we cannot hear you. Could you please do something with your sound or check the sound or maybe the connection? Maria, we lost the signal. Maria. Unfortunate happenings as expected, but my technicians are dealing with it, and I'm getting advices that perhaps we should need to move to the next speaker. I don't know. Let's give it another. Okay.
I think I fix my
Oh,
presentation.
excellent. We're now starting with the Sala Michelin from Brazil. Great to have you back. Go ahead.
Thank you. It's now working?
Yeah, totally.
Oh, so perfect. So good morning, good evening, good afternoon. Today I will talk about some works that we are doing in Amazon with my students and some colleagues at my lab, from our lab. And my relationship with Amazon is quite young. I started to do research there 4 years ago. And for a young biologist, the high biodiversity and the opportunities that we have in Amazon is like a paradise for us. Maybe some reason of that explain the high biodiversity for aquatic organisms is that we have many kind of aquatic environments, and they have each peculiarities that encourage us to study these places. But our problem is that we are losing this environment so faster than we can do research and know this real biodiversity. We are losing for deforestation, for burning. In this place will be used for land use in the future. Unfortunately, this is happen worse in the last years, and our indigenous people are not guilty for this deforestation, as we can see in some news from Brazil nowadays. Well, changing the environment are so fast that the landscape are completely different from each other. And also the variables that will affect these organisms will also be different. So what is happening with aquatic biota? What is happening specifically with aquatic macrophytes? When you think about odonata, for example, when we remove the marginal vegetation, we also remove the species that are sensitive, warm sensitive. So we have less species than in altered one when we compare it with preserved one. For this species, for odonata also, it's not the local variables that affect this group, but also spatial, and the biogeography also can explain the distribution of this group. for fishes that we have is that most important variable are the local ones, because when you remove the vegetation on these streams, we will also remove branches and leaves that give a structure for fishes. So in altered places, we also have less species than preserved one. But for macrophytes, that we can see is the opposite. When we have impact, we remove the riparian vegetation, we have more light in these streams, and also we have more diversity of macrophytes, richness and abundance also. And we can find some species that is like a biological indicators, like Utricularia. That is a species that we can find more in preserved streams. But when we also remove the riparian vegetation, we open opportunity for invasive species like Ural recta. That is, we found in our environment in Amazon also, and make us very concerned. We are concerned because Ural helps in the sedimentation process of the channel of our streams and rivers. As you can see here, this was the normal channel of this river, and now after some years, we just have this small one. So Ural works like an engineer species and change our entire ecosystems. And this happens because the accumulation of biomass of Ural is greater than the native species. You can see here in the simulation, when we compare native and invasive species in the beginning of the development, after a while, they still like the same. But when we saw, we have more time, we can see a high biomass below the water. And these affect our biota and all ecosystems. The effects of these invasive species also alter the diversity of macrophytes. So when you have high biomass, we have less species of macrophytes and also less functional richness. Together with Ural, we just found a small macrophytes, floating macrophytes that are not competing with Ural recta. And also, Ural affects the reproduction of the native species. When you see in a moderate competition, native species produce flowers faster, and the seeds is smaller than when these species grow alone. So these invasive species also change the reproduction time of our native species. Another species that we are monitoring is Ecornia crassips, but we know that it's native from Brazil, but many countries have problem with this species. Ecornia is found a moderate way in Amazon, and now what we are doing is to see the potential distribution of this plant now in Brazil, and doing this after to predict what will happen when we construction some hydroelectric powers in some streams in Brazil. Our first results show that probably we will have problem also with this plant close to these new hydroelectric powers, because they change the environment, and this is good for Ecornia crassips. The other work that we are doing with Ecornia crassips is to see the effect of this invader on macroecology partners. So we are doing work in Brazil and China, and see if the effect of this species in our environment will be more impact on China, that is invader, than Brazil. So we think that abundance, richness, and size of the organisms that live with Ecornia will be greater in China than Brazil. So for the future, we want to identify macrophytes knowledge gaps in Amazon and help to identify places for their conservation using modeling species, sample effort, and diversity. We also try to do more projects of synthesis, because when we if you can see here, if you compare the studies with aquatic insects and fishes and macrophytes, we can see that we have less works. But it's not because nobody was working with macrophytes in Amazon. Most of these works are the local interesting. So we need to put all together to see with a macro view what is happening with these organisms. And of course, discuss ideas and propose some projects with you. I'm excited about that. And all this work is not possible without partners. So thank you very much for all of them. They help us a lot to do research in Amazon and give us two structure for that. So everybody, if you want to come to Belém, are welcome, and thank you very much.
Thank you very much, Taisia Salamichelan, and it's always good to discuss the ideas with the colleagues. Great idea. We're now moving to Mansi Bakshi from India. Mansi Bakshi, hello.
Yep. Okay, hi, can you hear me?
Yes, we can.
Yeah, my slides?
Yeah, we can see it perfectly. Go ahead.
Okay, fine, thank you. Okay, so good evening, good afternoon, good morning, everyone. I'm Dr. Mansi Bakshi. I'm from India, and I'm currently working as a National Postdoctoral Fellow at Indian Institute of Technology. So my work is based on the exposure risk assessment of nano-sized titanium dioxide in the agro ecosystem. So to begin with, what is the need of the work? For example, about nanotechnology. We know that nanotechnology is a rapidly advancing field, and there's an extensive rise in the usage of nanomaterials and nano-based products. And this will definitely inevitably lead to the release of engineered nanoparticles in the environment. Now, nanoparticles can be natural or man-made, like engineered. So nanoparticles are defined as particles having at least a dimension between 1 to 100 nanometer as per the definition of US EPA. So the point is, what is the paradox? The paradox is that we have the rapidly increasing ability to engineer nanoparticles. However, their fate, behavior, effect, and release in the natural ecosystems, intentional, unintentional, in the manufacturing processes, or after the completion of their life cycles, remain unclear, debatable, and unknown. So my work is based on understanding the exposure scenario and risk assessment of nano-titanium dioxide. So why I chose nano-titanium dioxide? Because since nanoparticles are very difficult to detect in the environmental matrices, there is always a predicted or model concentration so far that has been that has estimated a possible concentration of nanoparticles like titanium, silver, zinc, carbon nanotubes. So in that exposure modelings, they have suggested that the nano-titanium dioxide has been found to be present as the highest concentration in surface water, sediments, natural soils, sludge-treated soils. So my study here is specifically focused on sludge-treated soils because sludge pathways form a very important or a chief pathway for release of titanium dioxide and other EMPs into the environmental scenario. Now, why nano-TiO2? Why I chose to work with nano-TiO2? I already told you that it is one of the most extensively produced, and its exposure concentration has been predicted to be the highest among all. Also, it is widely used, and its wide-scale applications range from cosmetics to foods, and it has many properties that makes it like a very important nanoparticle that needs an risk assessment. For example, bulk TiO2 is known as the environmental white knight. It is known as environmental white knight because it has a very generally positive acceptance by the public. It is biologically inert in animals and humans. That's one reason it's used in pharmaceuticals or in nutraceuticals. But the same does not hold true for nano TiO2. There is no mechanism as such to prove that it is toxic, but yes, there is no mechanism to prove as such that it is not toxic. So that is why I focus my work on nano TiO2. So there are two major release pathways, and the studies have also forecasted that soil will be the major sink of ENPs, especially agricultural soil. And the reason for this is that most ENPs are being used in agrochemicals like pesticides, fertilizers, nanoformulations, and above all for remediation purposes, including nanotitanium, which is being used for the remediation of organochlorine pesticides because of its highly active photocatalytic activity. And the model concentration of nanoparticle that TiO2 in seabed sludge has been predicted to be as high as 107 to 523 mg per kg for US and 100 to 433 mg per kg for Europe, and an expected annual increase of 89 microgram per kg, which is quite high. So the main objective of my work was to stimulate a realistic exposure scenario under which we would grow edible crops in agriculture fields where we would be using seabed sludge amendments that contain nano TiO2. So there is like a wide amount of literature that is available about that predicts the impacts of nano TiO2 on soil and plants. But most of these studies are carried out in hydroponics or foliar applications or using of nano TiO2 suspensions. Very few studies have actually gone and explored the impacts on soil studies or agricultural studies. Specifically, in a below ground population, nanoparticles have a highly known antimicrobial properties. For one reason, they are used as decontaminant agents in wastewater treatment plants because of their antimicrobial properties, and that's one reason they can be very, very harmful to the soil microbial population and community. So far, very few studies have worked on this in this direction, but yes, there are many studies that have explored their impacts on plants, and the literature is widely conflicted about what will be the possible on what is their possible effects. So in my objective, in my study, I worked on the seabed sludge amendment. I used the seabed sludge amendment that contained anthropogenic nano TiO2. I did not spike titanium in my lab or in my experiment. The seabed sludge that we received was produced in a wastewater treatment plant at the Swiss Federal Institute of Aquatic Science and Technology based in ETH Zurich. And the seabed sludge originated from the wastewaters of Dippendorf, which is like a suburban town in Zurich, Switzerland. Zurich is highly popular for its cosmetic industries. And this seabed sludge in our study, reported concentrations of nano titanium dioxide apart from background concentrations of natural titanium dioxide. So we use this seabed sludge along with an agriculture soil first as an amendment, and then we use these to grow tomato plants for a full life cycle study. We used a dwarf variety of red robin, which is like a dwarf variety because we wanted a full life cycle study. And then we assessed all the impacts of this on plant growth, development, phytotoxicity, elemental content, translocation, and biomacromolar changes. So to begin with, as I already mentioned before, that monitoring environmental concentrations of titanium in the environment matrix is very difficult. It is difficult than heavy metals or pesticides. So firstly, the seabed sludge that we worked on, we got, we had to check the presence of nano TiO2 against that in that. So for that, we ran microaxillary fluorescence. This was conducted at the European synchrotron facility in Grenoble, France, where we ran maps, XRF maps, and we found that in the sludge there was 46% of titanium was below 100 nm of diameter, which fit the definition and the range of nanoparticles. In the soil that we amended with the sludge, we found 20% titanium under 100, 50% in 100 to 30 nanometers, and the rest above 300 nanometers. And we also found further that 55% of the titanium was anatase and 45 was rutile. Anatase and rutile are two forms of titanium, anatase being more reactive than rutile. Secondly, and now the most important part, it is very important and also equally difficult to characterize titanium and distinguish between which is engineered and which is natural, because as I said that we have used an environmental matrix and not done any artificial spiking. So we had to we ran our Zane's map and we found that there is different in the behavior of nano titanium and in natural titanium. It is different in their toxicity and behavior. For example, the titanium observed in the sludge was composed of homo and hetero aggregates dominated by organic matter. So this is what we are talking about, engineered nanoparticles. And the natural TiO2 has a rough surface and it is included in organo-mineral soil aggregates with silicon, aluminum, and iron. So when we conducted our study, so this is the results of what we found in our study on tomato plants. So we found an overall increase in all the plant growth parameters. It is quite evident that we found an increase in plant yield in fruits and flowers in the seaweed sludge amendment, because obviously presence of high organic matter leads to an increase in the plant growth. That is one of the main reasons why seaweed sludge amendments are used in agriculture soils, because they increase the yield and they're a high source of organic matters and other plant nutrients. In the biochemical response, we found that most of the biochemical response showed insignificant results except for a decrease in tannin concentrations. In our elemental translocation, we found that the significant seaweed sludge amendment significantly increased the translocation of iron, boron, and sodium in all plant organs, while they decreased sulfur and phosphorus in leaves and stems. And similarly, manganese and silicon was found to be consistently lower in seaweed sludge exposed plants. I have the explanation for this. We can discuss it later. I can explain why this was reported. Then we ran a PC analysis for understanding the biomacromolecular changes, that is like for lipids and proteins, amides and lignins. And we found a significant impact on leaves. So in our PC analysis, we found there was a significant variance in control and sludge plants, or in leaves of control and sludge plants, less in stems and comparatively lesser in the fruits. Further, the FTR analysis also sorry, is there something? Okay. Also revealed that there was an increase in lignin, but a decrease in tannins, carbohydrates, and amides. So these groups are basically associated, especially at 1515, the lignin. This was a specific bond that was affected, and it affected amides and also tannins. Decrease in tannins is also something we found in our biochemical responses. Further, the most important part is what we found was that we did not found very low translocation and accumulation in all plant parts. That means titanium was not translocated to the plants. Thus, we can say we did not evidence proof of food chain transfer or trophic transfer potentials. So this is the paper that we published, and the major inferences was that there was alternation in macro and micro elemental content, while there was maximum changes in leaves and least in fruits. The future perspective is that the concentration of ENPs in plants can increase or decrease the toxicity when they come in contact with other metals or pollutants, like heavy metals. This is known as the Trojan horse effect, and we really need to see and work on this aspect. And similarly, we found in our studies that leaves are the most impacted organs in both FTR and biomarker elemental analysis. So we predict that that future studies targeting crops with leaves as the ediparts are needed, and also studies with more full life cycle and trophic transfer potentials are needed. So my present and future work is focused on the Indian scenario, where is very limited data is available, and I hope I would be able to start my work very soon. So this is the reference, acknowledgement, and thank you.
Excellent report on the application or on the study of nanoparticulate titanium dioxide, widely used material. I think every industry involving this material into their products should consider your research. Thank you again. We have Maria Gordieva back.
Hello once more again. I don't know
I see we
what
resolved
the
the
problem
connection
with technical.
problems.
Yes,
Yeah.
I think
Great
somewhere
to
with
have you
Wi-Fi.
back. Go ahead.
From what part of the
Oh, you may start with the
topic?
beginning. That's okay.
Oh, okay. So once again, the theme is integrated assessment of the state of water ecosystem. Do you see the presentation? Hello? Do you see the presentation?
Yes, we can.
Okay, it's great. Let's start. Since ancient time, people have settled near water, which have played an important role in their lives. In this context, water resources should be emphasized as an essential element of economic development, taking into account their social and environmental benefits. Water pollution is currently one of the major environmental problems of urbanized areas, as stated in decision of the 8th World Water Forum. The quality of water and feed inputs in conditions of industrially developed regions with a high degree of anthropogenic impact on the territory became especially significant factors. The fact is connected not only with the increase of population, but also with the fact that preference is increasingly given to healthy food. According to FAO data, mankind annually consumes 90 million tons of products produced by aquatic ecosystems, including 30 million tons of aquaculture. In the 21st century, 130 million tons will be needed to address the nutritional needs of the growing population. However, fishing can't continue to address the growing demand for fish, and its catch has reached a relatively stable limit since the mid-90s and amounts to approximately 90 million tons, but not more than 100 million tons per year. This calls for the active development of artificial system for the cultivation of hydrobiomes. I mean that closed water supply system, where controlled water quality is particularly relevant for the successful cultivation of valuable fish species. The normative documents of the Russian Federation describe complex indexes, integrated indexes for water quality, which have been tested for many years, and accurate integrated indicators of water status. However, there are quite a number of indicators, for example, index and another, which take considerable time to measure, up to several days. In some cases, respond to the changed state of aquatic ecosystems is required quickly to prevent the effects on hydrobiomes. That's why we have derived a water quality index. One second. A water quality index which allows quickly assess the water quality by the degree of pollution, using a promising integrated indicator, the total antioxidant activity. And in accordance with microbiological analysis, we dedicated zones of water saprobity. It is Aliga, Meza, and Poly. This index is based on a long-term study of abiotic characteristics of ecosystem, basin cooler, of energy facility. It is an integral part of my scientific work, and we are used to hearing that using water reservoirs of energy needs only has a negative impact on aquatic ecosystem. Is there any merit to this? And I decided to start from this first indicator, it is temperature. First of all, it is necessary to note the general change of the maximum of water temperature in the middle band of Russia have increased by 24% in lakes without heat effect, and by 38% in the lakes with heat effect in comparison with the beginning of the 19th century, and shift of the temperature maximum from June to July. The amount of classical temperature period described by Zirnov in 1934 decreases from 6 to 5. The duration of the temperature periods is changed. First of all, the period of summer stagnation is increased to 2 months. There is no ice cap on the zone of temperature impact. which leads to improved oxygen condition during the winter time, and it is particularly important for hydrobiomes. This opens up additional opportunities for aquaculture. This is an example of mathematical modeling of temperature impact on basin cooler in summer period. That's, despite the significant increase of temperature in the summer, the values of dissolved oxygen in the surface layer of water are similar to the values with natural temperature regime. It is in summer and autumn, and increases by 81% in winter, and in spring, in the wake of flowing of oxygenated water from the open offtake channel of the combined heat and power plant and absence of ice cap. That's why it is additional opportunity for aquaculture too. The another factor is pH and redox potential. At the same time, pH corresponds to the mild alkaline reaction of the environment throughout the year. They were in the diapason from 7.5 to 8.5. There are acceptable values for the cultivation of valuable fish species. The values of redox potential in the summer period rises to 24% and decreases in the autumn and winter period by to 29-74% accordingly, if we compare to with lake without industrial pollution. And the physical-chemical factor is indicator is total antioxidant activity, and it is one of the most popular chemical indicators today, and at the same time the least studied. We are currently in the process of classifying waters according to the total antioxidant activity indicator, and we have identified 10 water clusters, which you can see in this chart. But in this chart, you can see only 7 clusters because we have some problems with 3 clusters of water. And another point in what I want to state is bottom sediments. Chemical pollution accompanied by a change in the hydrological regime with the presence of increased water exchange leads to a change in a dominant type of sediments from large aleurotic silt to small aleurotic silts. And in the northwestern part of the sea, characterized by the presence of flow as a result of the work of combined heat and power plant, the rate of sedimentation is on 1.5 times lower than in the southeastern part of the lake. Under conditions of industrial pollution, there is an excess of the background content of heavy metals in the sediments, for example, copper and zinc. And the problem with excessive concentration of heavy metals, we decided by creating the bioplateau. You can see in this slide the bioplateau, and of all the types of water after treatment, the most simple, mobile, and economical methods which simultaneously provides the possibility of combining decorative tasks with improving water quality is biohydrobotanical methods. The organization of bioplateaus with the inclusion of highest aquatic vegetation in purification processes. You can see the species of which we include in bioplateau. Aquaponics, on the right corner, is a similar promising direction of using plants for water treatment. Aquaponics is a new high-technology agricultural technology that combines both the cultivation of plant products and the production of fish products. During the process, plant consumes the products of release of living organisms that they need, chemical substance dissolved in water, and at the same time naturally purify and enrich it with oxygen. The production process eliminates the need for the use of various chemical fertilizers with a complex system for their dosing and storage. The process of chemization, processing, and purification occurs naturally and in closed cycle. Thus, aquaponics mimics the natural whirlpool in nature. So the study of physical-chemical indicators of water, it's possible to devote redox potential or YASH as one of the relevant indicators for monitoring the state of water systems when growing and cultivation hydrobionts in a closed water supply systems. YASH is more promising indicator, and first of all, for our opinion, it is an indicator easily controlled by instrument method. Numerous measurements of the YASH of the natural waters of the Tatarstan Republic revealed that 1 unit YASH of PASH corresponds to 59 millivolt of YASH. This makes it possible to consider that redox potential are most sensitive indicators in PASH, thus devote time to respond if need to improve water quality. For example, to reduce cultivation density, to increase runtime, to change pH. The experiments have confirmed the sensitivity for the redox potential to water quality decline using the closed water supply system. We identified zones for death, for operation, and for normal existing and optimal existing of valuable fish species. It was found that YASH indicator shows a change in the state of aquatic ecosystems on 36 hours earlier in a closed water supply systems. This allows you to quickly respond to change in environmental conditions. So, in the conclusion, one of the most effective ways of recycling low potential overflow water is creating energy biological complexes. The index of water quality has been developed, which makes it possible to assess water quality by the degree of pollution by using a promising complex indicators of total antioxidant activity. And it is possible to use the redox potential as a complex indicator for assessing water quality if redox potential will be ranked and the water quality scales will be prepared. So thank you for your attention, and I will very happy to answer your question if you have.
Well, we surely will move to the question right after all speakers have done their reports. Thank you very much, Maria. And that was an excellent report for all fish lovers, of course. We're now moving to Honghu Liu from China. Honghu Liu, are you there?
Hello.
Hello.
Listen to me.
Yes, we can, but we cannot see neither you nor your presentation. Oh, now it's fine. Go ahead, 12 minutes.
Okay, thank you very much, Mr. Chairman, ladies and gentlemen. I'm Honghu Liu, come from the Changjiang River Scientific Research Institute in Wuhan, China. My talk title is The Retreat of Gully Erosion and its Hydrological Analysis in the Southern China. My talk including the further parts. First, I shall report the introduction. We selected 4 soil types to study real developed and rainfall simulator. It is very easy to discover the different slopes, the position, shape, depths, width areas, volume of the real amount of soil type. For example, the black soil, the real in black soil is very long and narrow, while the red soil is wide and deep. Bunga is a special erosion type, and the combination of the hydraulic and activity is one of the gully erosion type, which is very similar the Madagascar USA and the southeast of the Brazil. Until the 2005, there were the 239.1 thousand gully in 36 counties of the 7 provinces of the southern China by the artificial survey. Total gully area was the 1220 square kilometer. Gully area would test the land resource, deposition gully channel, and pollute water body. Now, number of studies have been conducted to the measure gully head retreat rate in the southern China. However, a long series of gully measures are very scarce. The following is the material and method. The study site is located in Zuoma, small catchment Yudu County, Jiangxi province. The right side is the detailed information. We select 2 gullies. One is old. One gully is the old large, and the other is young and small. We use the 3D scanner to measure the gully gully 5 times from the 2009 to the 2060. In total, spanning a period of the 7.5 years. The right side, the 2 gullies, right picture displays the gully evolution process and human intervention. Gully E was the board and repaired for the construction in April 2016. At last, we can get the DM with the grid space of 0.05 meter times 0.05 meter. We can get the gully parameters. For example, gully the bordering line, slope, gradient, project area, gully volume, and 3 area of gully system. The parent material is the weathering resiliency of the granite up to a depth of 20 to 60 meters. The X permit negative should quarters content at about 70%, clean mineral content ranges from the 26% to the 30%. And the value sharing the sample show content is greater than 90%. Clean is bigger and bigger from the surface deep soil layer. The rainfall reversibility is commuted by this equation. The surface runoff is commuted by the CSCN, the method developed by the USDA CSCS. The rainfall averagity was the corresponding to the received rainfall. We divide the average rainfall averagity, and the rainfall runoff based on the gully monitoring stage. The following is the result. Average between gully head and gully outlet changed from the 27.54 meter to the 30.77 meter for GE, and from the 13.89 meter to the 17.15 meter for GB. In other words, gas depth increased by the 3.26 meter and 3.23 meter during 7.5-year periods for GE and GB respectively. From these figures, we can see that both galley were still active. Galley head retreat of GB was first, then that of GE. Total retreat distance was the 3 to 4 meter for GE and 8.28 me for GB. They mean the retreat rate of the GE from 2009 to the 26 was the 0.46 meter every year, while that of the GB was 1.1 meter every year, more than twice as much than that of GE. Slope grid was about 60, in some cases even up the 80 degree in Great Wall, while it ranged from the 20 degree to the 60 degree at the gully bottom and 0 degree to the 40 degree in the deposition area. Means the slope gradient of gully wall was about 65 degree and 70 degree for GE and GB respectively, while that the depositional area in both gully was about 50 degree and that of the bottom area decreased from the 35 degree to 50 degree at the beginning of the study period to the 20 degree at the end of study period for both gullies. From the table 1, we can conclude the S of the poly gullies shows unenclosed over time as well, with the 16.57 square kilometer every year and 25.52 square kilometer every year for GE and GB respectively. And the similar, the gully volume, the retreat rate of GB present very high correlation with the erosive rainfall depth and the rainfall velocity than GE. The best of the 3 daily rainfalls seashore was 25 millimeter for the hydrological variable with the retreat rate. Gully A has a weak correlation with the erosive rainfall and rainfall erosivity, which has largely due to the low retreat rate in the interval of the 2011 to the 2013. Gully retreat have a better relationship with the runoff depth than the runoff amount.
1 minute.
The linear regulation model includes a significant combination of GHR with hydrological variable at a p equal 0.05 using an f-test. The last is the conclusion. We can conclude the measure process of gully head retreat seems to be the mass the movement by gravity and the soil saturation. Two, average retreat rate to gully was 0.46, 1.1 meter every year. Slope 3. Slope gradient of the gully wall is very large, which is 65 to 7 degrees in average. Gully head retreat or the collection with the gradient of equal to 25 millimeter rainfall depth and rainfall averagity. That's all. Thank you very much for your attention.
Thank you very much for the very great job, and you did a great work on the studying the rainfall soil erosion. I appreciate you for that. And now we're moving to Pananani Ananya Ramolifo from South Africa. Fananani, are you there? Hello.
Hi, can you hear me?
Yes, we can.
Oh, nice. Good afternoon, everybody, and to those who are in South Africa, happy Heritage Day. My name is Ramlipo Pananani. I'm a postdoc fellow at the University of Venda. I want to share briefly one of the chapters of my PhD entitled The Role of Climate and Global Change Factors in Mayfly Community Structure. This is the case study of the Ruvubu River catchment. Studies have been done in the SADC region, particularly focusing on long-term stream flow and water temperature regime. So the general conclusion from those studies has been that stream flow regime is on the decline course, particularly for the SADC region or southern part of Africa. And the same to water temperature in streams. It's increasing in streams in the southern region. Of interest amongst in the catchment that I studied, the study looked at long-term stream flow for the past 8 years, and the outcome from that within the Ruvubu catchment is declining, and such a decline is more pronounced during the summer season. And as such, the study concluded that the stream flow is projected to cease can be the case. This will have a very significant impact, particularly to the aquatic biota that depend on this stream flow and water temperature regime for their habitat and refuge. So my chapter was to determine the role of environmental factors such as stream flow, water temperature, and others that I collected in determining the metrics, particularly for one particular aquatic group, which is the mayfly. We also wanted to determine indicator species within the mayfly group that will this species should be so this should be that particular metric that will tell us that the system is now changing. And we also wanted to determine what point exactly within these environmental factors does the change start to have a severe impact, particularly to the aquatic biota. So we looked at the Ruvubu catchment, like I said, which is located at the northeastern tip of South Africa, as you can see from the map. So the main river course of this catchment, which is the Ruvubu River, flows eastwards, then into the Kruger National Park, which is where my highlighter is. which is the one of the largest wildlife conservation area. And this it's not only that the river also forms an international boundary downstream of the Kruger National Park between South Africa and Mozambique, and also between South Africa and Zimbabwe. So it's really one river which is of great influence within the local ecosystem. So we selected 23 sites that we monitored for not less than a year within the catchment. From these sites, we collected hydrological data, which included variables such as stream flow, water temperature, river depth, river width, and other in situ variables. We also collected biological data, of which my chapter, this current chapter, focuses on mayfly, though we even collected many other groups. So those of you who may not be familiar with how mayfly look, this is how these are different families within the mayfly group. So this particular group attach themselves on the rocks that are submerged below water in the riverbed. So what we did in those 23 sites was that we selected, in each site we selected 6 random rocks that we dislodged these particular species that are attached in this rock, where we went on to filter or to identify mayfly group into the species level. So our sites ranged from those that are relatively pristine, such as the Zindi River and also the Chirova. However, we do have within the catchment streams that are barricaded, such as the Ruvubu, where we've got a large impoundment that has been installed, the Nandoni Dam. We also have rivers where local people do carry on their domestic activities, such as what is happening in this image on the screen, where people are washing. So statistically, from the data that we collected, we ran amongst these factors, which ones are responsible for the richness of this group. We also fitted the multivariate generalized linear model to determine what of those factors are responsible for the abundance. We also use the it's a package in R that determines indicator species and also shows us at which point do severity of change start to happen. So we collected more than 11,000 mayfly larvae that were grouped into 19 species. From these species, at each site, the diversity ranged between 3 and 15. And we also had really experienced the least, which was Afroptilum sudafricanum, was the least common species of the species that we found in our sites. So the factors that were major drivers of diversity included the survey date, TDS, elevation, and temperature of these variables that were part of the best model that explain variation between species diversity. So temperature was the most significant of these particular variables. For those that determined abundance, we found that this abundances differs between sites. So site was factored into the models that we ran. So we found that just because site A differs from site B, so that on its own was one a predictor to say the abundance of sites would not be the same throughout the 23 sites. So site was one of the significant variable that was fitted in our models. Again, we see temperature also accounted for these abundances in the different sites, and also we see stream width, the size of stream also do matters for this particular mayfly group. So as far as indicator species and where exactly do the critical change start to occur, we selected the temperature gradient because this particular variable was the most common and was the most significant of the other variables that that accounted for either diversity or abundance. So we chose to work with temperature to look at what particular species would tell us if temperature is starting to change, and at what particular point, degrees Celsius, would temperature start to have severe effects if it does exceed or become less. So we found that it was only one species, which was the cynet, which seemed to increase with an increasing temperature gradient. Yet the other 5 species that were identified by the model, which is Nigrobetis, Euthralas, elegans, and the other one, Betis arison, these species seem to favor more cold waters. But when temperature goes beyond this region here, which is between 19 degrees and 20 degrees Celsius, this with temperature that goes beyond that particular region. So it was only one species that seemed to favor temperature increases. So in conclusion, we come again.
1 minute.
Okay, so yeah, we found that temperature is one of the most important variables in structuring these aquatic groups. And for the mayfly group, we saw that if our rivers start changing and increasing their thermal regime and goes beyond the 19 degrees Celsius, be it through climate change or man's influence, will lose majority of mayfly species. So mayfly, our conclusion was that mayfly is a very good indicator of thermal regime changes in these rivers, and natural temperature in rivers should really be protected if we are to conserve these species and others. So for my PhD, for this chapter, we published these papers, which I'm happy to share if anyone is interested in going through them. So I want to thank you all for this time that I had to share my research. Thank you.
Thank you very much, Fananani. Excellent report on how fragile could the biomes be upon the temperature rise and possibly affected by the climate change. Excellent report. We're now moving to the discussion, and we still have a few minutes left. And as I could witness, there was an intense dialogues between Taisha and Dmitry, Prasenjit to Mansi and Semakaleng to Mansi. And since Mansi had a lot of questions to answer, could you please list or just briefly sum up what were the questions? Mansi, are you there?
Yeah. So I already mentioned, and Prasenjit asked me that what would be the we did the yes, I did the heavy metal analysis, and we have already published the data that it was under the permissible limit as given by both Europe and USA. So we did have, we use 1:10 as sludge to soil ratio because that's what is the standard used as amendments in agriculture fields. For the other question that he said, that for the PC analysis, so what we did was we selected a fingerprint region in our analysis of, which was like from 155, 175 to 455, which is something that we found, and in that fingerprint region, we did the PC analysis for the FTIR graphs. And apart from that, he asked me about the preparation of the for the XRF maps. So what we do is that we have to preserve the sample in a cryogel, and then in isoheptane, and then in liquid nitrogen, and then we have to transport it to the ESRF facility where they slice the sample or cut the sample in a microtome, and the way TEM and SEM is done, but a little more sensitive. And after that, the beamline scientist would be analyzing the sample and not me, because I'm not allowed to enter that. And then we would be running the maps, and we able to find what we are looking for. Like, for example, we are trying to find titanium and whatever. So these maps take a lot of time. We have like a slot of 3 days, and in 3 days we need to find what we're looking for, else the slot is over, something like that. Anything else? Okay, I have some messages.
Thank you very much, Mansi, for your a great response. And I've seen that Dmitry asked a few really huge questions to Taisha. And Taisa, could you briefly sum up what were they about? And I assume they were really good questions.
Yeah. Yes. He asked about Ecology canadensis in Brazil. They have a problem in Russia with this species, but in Brazil we don't find Ecology canadensis in our environment. This is curious because we found to sell for aquariums, but in our environment, this plant is not a problem for us. We have another ones like hydrilla, come from Asia, but not from Elodia. And the other question is about migrate with macrophytes. When we have problem with this point, because macrophytes grow with the flow of the water. So many humans cut these invasive species to try to remove from the streams close to this house. But when they cut, they produce some fragments that go with the water, and these plants start to develop from some meters or kilometers below the water.
I see. Taisha, you see, Pedro Brancaleon is asking you a question. Are you trying to restore some of these streams in the Amazon? Have you controlled some of these invasive species somehow?
Not yet. We will start to monitoring some streams, but we need to, for Ural, we need to start when in the first steps, because when these species grow so fast, it's impossible to remove them. So we are looking for places that these species just started to development.
I see. Thank you very much for your answer. Fananani, Semakaleng has asked you a question. Could you publicly answer that question?
Hi, Isma. The choice of this particular group, like I said, what I presented here, it's just a portion of what I did for my PhD. So we had a number of other groups that we looked at. But this particular one, why we chose it, the fact was that it's a very diverse group, and it's a habitat specific. You know that if you go to this particular habitat, you will surely find it. And again, it's very localized. It doesn't have mobility advantages, so it doesn't. It's really very easy to work with because you can easily catch it, and you can also easily identify it. So those were some of the reasons that we chose Mayfly group amongst the other groups that we also chose.
Thank you, Pananani. Thank you for your answer. Unfortunately, we're up with this session, and we have to now move to the to the coffee break. After which, we all gonna be connected to the experimental session. Please stay in line and leave your questions regarding the experiment in the group chat. They're going to be transferred to the experimenter, and he's going to be able to answer that. Well, it was a great pleasure to moderating your session with you guys, and see you soon next day. Bye bye.
You've been here, but you've been missing for some time now. Yeah, yeah. Every time I see you, it's a different vibe now. Yeah, oh. I can't help but let you just slip away. Oh, oh, oh. Can we get back what we had yesterday? Oh, oh, oh.
If I ride with you, better know that I'ma ride for you. Better use a gun or knife for you. I ain't finna choose the side over you. Yeah. If I ride with you, ain't nothing to provide for you. Ain't nobody in my life like you. Ain't nobody gonna shine like you.
Show me my love. Oh God, show me sweet love. Yeah. Show me my love. Oh yeah. Show me sweet love. Yeah. See, show me my love.
My team, we on a new team. My mink dragging like it's Luke King. My show pack, all the dimes there, but I be falling back from all the loose change. I drop the top on that new thing. My chocolate bra, they rock Gucci. Gotta know it's impossible to stop for Lauren. Got the box, I want the new thing, yeah. She gon' show out. Before it's Wahala, roll out, yeah. She gon' show out. Before you break it down, girl, roll out, what up? If I ride with you, better know that I'ma ride for you. Better know that we can live for each other. That don't mean I gotta die for you.
Show me my love. Oh God, show me sweet love. Yeah. Show me my love. Oh yeah. Show me sweet love. Yeah. See, show me my love.
Yeah, bring 'em out. Hard to hear, too many girls in the house, hey. Bring 'em out. I started here, I got the buzz in the cloud, I know. She got it all, but got nothing to hold. Every time I saw her, not too many know. She ain't really hard, she act because she hurt, yeah. And I could be your last. Lead the past with your first.
Show me
work.
my love. Oh God, show me sweet love. Yeah. Show me my love. Oh yeah. Show me sweet love. Yeah. See, show me my love. is all it takes. Falling in love with me. Possibilities. I look like all you need. Let me take the night, I love real easy. And I know that you still wanna see me. On the Sunday morning, music real loud. Let me love you while the moon is still out. Something in you lit up heaven in me. The feeling won't let me sleep. Cause I'm lost in the way you move, the way you feel. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need. I just wanna feel your skin on mine. Feel your eyes do the exploring. Passion in the message when you smile. Take my time. Something in you lit up heaven in me. The feeling won't let me sleep. Cause I'm lost in the way you move, the way you feel. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need. See wonderland in your eyes. Might need your company tonight. Something in you lit up heaven in me. The feeling won't let me sleep. Cause I'm lost in the way you move, the way you feel. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need. One kiss is all it takes. Falling in love with me. Possibilities. I look like all you need.
I understood loneliness before I knew what it was. I saw the pills on your table for your unrequited love. Oh, I would be nothing without you holding me up. Now I'm strong enough for both of us, both of us, both of us, both of us. I am a giant. Stand up on my shoulders. Tell me what you see. 'Cause I am a giant. We'll be breaking boulders underneath our feet. I am, I am, I am, I am, I am, I am a giant. Oh, I am, I am, I am, I shake, roll away in the dirt under me, yeah. I'm gonna shake, roll away in the dirt under me, yeah. I'm gonna shake, throw it away in the dirt, yeah. I'm gonna shake, throw it away in the dirt, yeah. I'm gonna shake, throw it away in the dirt, yeah. I'm gonna shake, throw it away in the dirt.
One Young Scientist Forum. Now it's time for the lab experiments. We will see 5 experiments held in 2 different labs. They will be explained by Sergei Sapozhnikov and Pavel Taranenko. In case you have any questions, you can write them in your Zoom chat rooms, and we will be able to forward at least some of them to our scientists to hear to what they have to answer. So right now, please enjoy the lab experiments.
Hello, everybody. We are in the laboratory for experimental mechanics of South Ural State University. As you know, mechanics is the oldest science, but it is around us to deliver safety and comfort. Let's go to experiment number 1, connected with car step platform vibration tests. Please, Pavel. You know, any modern car is nice, but sometimes dangerous by suddenly failing. That's the reason, before the use of cars, to test their components carefully. This is done in order to confirm the strength and reliability of the structure and make sure that the car elements do not fail after a short operation. One of these tests is vibration testing. Existing structural elements are placed on a vibration stand and simulate in a laboratory the load arising in real operating conditions. The online experiment will demonstrate vibration tests on the step platform of the modern Kia Seltos car. Now you can see experimental facility, shaker and sleep table. Test object, as I said, step platform of Kia Seltos car. The schedule of the experiment is: before the experiment begins, a step platform of Kia Seltos car will be installed on the vibration table. You see now it's done. Next, the load program is set on the computer, the level of acceleration and excitation frequency. Now vibration table system activated. The control system is activated also, and the table of this shaker is set in motion. The operating mode is displayed on the computer. You may see them, and control system screen. After a while, the experiment stops. We make sure that the step platform remains intact. You see, it's okay. And no rupture, it can be put into real operation condition. I can add that this structure consists of aluminum part and plastic parts on the end. And if these parts are good, that this step platform will be good in operational conditions. So the noisy atmosphere is finished, you can ask me if you have a question, please. I guess it's clear.
Yeah, no questions
Absolutely.
so far.
No question. Okay. Okay. Let's go to the experiment number 2. Okay. This is our new point of view, point of attention. This is drop tower. Drop tower. Very nice machine. It can apply dynamic loading to the sample or piece of structures just in this chamber. This chamber can be cooled or heated before the test. And now you can see all details of this machine, and engineer Anastasia will close the doors, but you see a sample, small prismatic sample with groove. This sample will be loaded in bending dynamically, and if the load will be high enough, this sample will destroyed into 2 parts, and we will see the result. Before the production of valuable products and put into operation, the properties of the material from which they are made are determined. It is needed, for example, for pipelines and transport oil and gas do not collapse when internal pressure is applied. Before the pipeline is manufactured, the steel properties are checked for compliance with the required characteristics. To do this, the number of mechanical properties are determined: ultimate strength, yield strength, plasticity, impact strength. Now we will use impact testing machine. Yeah, please. Put. You will hear drop. And after that, we'll see the result of the experiment on the screen as a function of load versus time. Just a moment. All parameters will set. Initial speed, high drop of weight, and impact energy. You will hear sign like beep. Okay, experiment is finished, and several seconds to computer take all results, and after that you can see on the screen this function as I said before. Yeah, and please open the door, Anastasia. Just a moment. The machine will be prepared for next experiment and safe to open the door. It's okay. We can see the 2 parts of one sample, and one part is lost. Yeah? Where is it? Jumping up. Okay. Okay. Put here, please. You see the groove, and from this part, the crack was going through the thickness of the sample, and the test is finished. You can see different objects for testing on this machine. This is the same test for fracture toughness, and here a small sample for the dynamic tension. And this is impact test of composite materials with round support and then drop inside and cracks on the back side. After that we cut sample and test it for residual strength. In this sample you can see plastic with the trace of impact and the kind of hill on the back side you see. This is the result of dynamic loading different materials, metals, alloys, superalloys, composite materials, and plastic. That's all. The second experiment. If you have questions about drop tower and dynamic testing, please, I'm ready.
Yes, there are several questions. One of them is about the first experiment. The question is, did I understand correctly from the first experiment that Kia Seltos's part is quite reliable?
Now we can say yes, because Kia Seltos step platform is absolutely without defect after vibration test, and we can say that exploitation of this part will save.
All right. The next question is, can we use this device for the soft materials?
Which device?
I don't know. That's what they wrote in the question. I think the one where you tested the sample.
If the question was about shaker, yes, why not? But soft material will have much more amplitude of vibration. It may be some problem for determining this displacement. If the question was about drop tower, yes, we can use it too, but energy of impact will be not so high as for metal sample.
Several more questions. Is the rate of vibration altered? And what is the maximum and minimum points in meters per square second? Question from India, from Sayantan Sinha.
In this shaker, we can apply acceleration up to, if I remember, 1000 100 G, no more.
All right. Another question is from Prasenjit Ghosh. What is the sample specification, and why was the groove made?
All tests provided with standards, and the dimensions is according to standards, especially for toughness. We have this sample with size 10 millimeters to 10 millimeters and 60 millimeters long. Groove is special in the center to locate crack in needed place, and all the dimensions according to standard. I don't remember real number of this standard, but it's very well known in scientific literature.
There are a few more questions. What was the yield strength of the sample, if you remember?
For this steel, this is low carbon steel with yield stress strength about 300 megapascal.
All right, thank you. Next, what is the purpose of this test with respect to practical application in machines?
This purpose of this test connected with sometimes choosing one or another material, because in real structures we always have stress concentrators, and the possibility of sudden failure is not 100%. So we need to test different materials and choose proper materials, maybe to change some parts after 10 years or much more years after exploitation, old parts to change for new, and these new parts should require some rules, and checking of fracture toughness is obligatory.
Great.
For material.
Yeah. Now a long one. A lot of data must be generated from these experiments, the first and the second. What type of predictive experiments can one derive from this to simulate car accidents as well as determine the physical properties of less known alloys and compounds and their response to stress?
As I truly understand the question, it's not short question, because for real materials, for real parts, for real structures, at first we use finite element modeling with taking into account mechanical behavior of steel or alloys, and after right calculation we try to check our calculations with these experiments in our laboratory. If experiments compare good with calculations, then calculations is right, and then we can go to next step to prepare production site, and then to exploit this construction, this structure. If not, we should change maybe some materials or make a model, a finite element model, more correct with more details. And this cycle is not one. Sometimes we change materials or change subject several times, but finally we will get proper material, proper structure to safe use for people.
Great, thank you very much. Some more questions. How dynamic are the data sets and what features are collected from these dynamic load experiments?
How dynamic?
Yes.
Because drop tower is a dynamic machine, all period of contact impactor and sample may be 10 or 12 microseconds. So we have acquisition system with megahertz frequency.
All right. A question from Anton Nurkenov. Can you give examples of projects implemented within the framework of creating digital twins based on the test results?
We have not one, but less than 10 projects with digital twins, because all modern structures, all modern projects are not only experimental, but connected with different kind of modeling, different depth of this modeling, and digital twin is special things to better understand what we can change in real structure, not getting experiments, but only testing with this twin. We have next experiment will show flow meter, and for this subject our team created digital twin, and they can tell you more than me.
All right. We have a question from Yevgeny Alexandrov. What is the strongest material you studied?
I can say that about 2000 megapascal ultimate strength. This is bulletproof material steel. And more strength material is carbon fiber reinforced plastic along fibers with the ultimate stress about 3000 megapascal.
Great. And one more question. Let's say that an experiment shows a bad result. How to determine what you have to change in the material to make it stronger?
It's not a question for me, for us, because our laboratory is a laboratory for testing materials, not for production materials.
Great. Well, I guess that's it for the questions so far. Why don't we move on to the next experiment?
Okay. Let's go to third experimental place. So this is effect of gas bubbles on flow meter reading. Please, Pavel. You see the Coriolis flow meter, which is designed to determine the mass flow rate, for example, of oil and gas products. This flow meter has a very high accuracy, which is reduced when gas bubbles enter current fluid. Moreover, there is even a shutdown to the device. Thanks to improvement of the flow meter, it's possible to ensure the stability of this operation, especially when gas bubbles appear in the flowing fluid and even when there are quite a lot of them. However, the measurement errors remains high enough. There is test rig, a flow lab with flow meter through which water is spilled with a mixture of air bubbles. Do you see these bubbles? Pavel? Add, please. Okay, many bubbles. The operator turns on the power and water pump is set and mass rate of flow going first. We observe flow meter readouts. Air is in flow. Okay. Pavel, is it possible to see the change of flow in your apparatus? Just a moment. Some changing flow. Okay, you see the changing of results. And one more. Bubbles, you see, significantly change the process. You understand, if the flow meter will not write, we will pay more. Agree? Or sometimes pay less, but it's not for us. It's okay? I think the demonstration is over, and then you may ask me or Pavel.
Yes, we are still waiting for some questions. Yes, we have a question. Can the change in flow study be carried out for both Newtonian and non-Newtonian fluids?
Oh, it's quite complex question for me, but in typical situation, liquid is close to Newtonian. It is gas or even water with gas, not so viscous. Then I cannot say something about non-Newtonian liquid in this flow meter.
Great. And it looks like we have one more question. I'm just waiting for it to appear on my screen. Why is this experiment essential? And where are the results used?
The Coriolis flow meter is the best now for measuring flow. So if we have to get less error, we need to change slightly maybe structure or design of this flow meter, or regulate some parameters of this flow meter, or maybe changing total structure of the flow, and then we will have maybe this work is not finished now, maybe to increase so-called less errors. We need to have much less errors than now. Errors of flow meter now is how many percent? 0.1% is typical error of flow meter like Coriolis. Another system from flow meter have much more error.
Great. Thank you very much. It looks like we don't have any more questions.
Okay.
Do you have any more remarks to make?
I think the specialists will give you more details, but I have only total view.
Excellent.
Maybe let's go to fourth experiment.
Yes, sure.
Okay. Let's go to this stand. Vibration-based diagnostics of rotor defect. Defects in the elements of the rotor, gears, and are determined by the sensors reading installed on the rotor supports or directly on the rotor shaft. This is. The experiment consists of a signal release from a rotor using a sensor that rotates with the shaft, transmitting the signal to a computer, processing it and interpreting it. This facility consists of rotating shaft with PCB installed on it, and there are accelerometers placed on board. Let's go to experiment. An acceleration sensor developed by our university is installed directly on the rotating shaft. Then the operator sets the shaft speed, press the button, and outputs the shaft to operating rotation. Now we demonstrate the non-defective and defective parts. Can you show, Vladimir? You may see non-defective and defective part with one teeth is out, was out. I think it's clear. It's right and bad part. Okay, thank you, Vladimir. Now we can see the result of this experiment on the computer screen. To show the results of testing with defects and without, maybe. Information is going to computer. Connected. Show, please. Yeah. It's a signal in time. Yeah. And where is defective signal? All of this. And you see here comparison of spectrum signal with ideal and real with defect shaft with supports. Blue is defected and orange is good, non-defective. So this technique allow us to know where is defect part without disassembling. This item is item of Vladimir PhD thesis, so it's very nice modern investigation. That's all. Thank you. Please question.
Great, thank you very much. I hope Vladimir succeeds in his thesis. We have a question
I think yes.
Yes, we have a question on the previous experiment.
Okay.
Do you ever measure the different viscosities of liquids or just flow rate in water?
Typically water with additives.
Okay.
At room condition. The question was about Coriolis flow meter. Maybe different temperature or viscosity, Pavel? Yes? Oh. The author of this machine say they tested different liquids with different temperatures, but not so high viscosity for that.
All right, thank you very much. We have a question from India, from Avinav Sharma. Is this an in-house calibrated setup?
Calibrated for
I think
Coriolis flow meter?
Yes, they mean, did you calibrate it yourselves, basically?
Because we were working with a real company to production of these flow meters. They have a calibration system, and after that we used this device in our laboratory. We need to understand that calibration system is quite big.
Yes, of course. Thank you. It looks like we do not have any more questions.
Okay.
So any final remarks? Do I understand it correct that it was your final fourth experiment from this laboratory, right?
Yeah, but it's not all experiments we can do this. We have much more machines, techniques for making experiments, not just in this laboratory, because laboratory for testing materials is not only one place. We have at least 3 places for static testing, this laboratory for dynamic testing. We have not so long time for show our abilities, so this is much more interesting than others.
Excellent. Actually, we have one more. I'm sorry, yes, but we have one more question. Maybe the last one for this part of the labs. How can we interpret data from the spectra that a part of the machine is defective?
For this technique, we use special software developed by our colleagues, because it's not easy to explain into words, but you should understand we did not try to use technique without checking, and this machine we showed you with right part and wrong part, and then we connected these results with calculated results, and then we can say our methodology is right or not.
All right, well, great. I think that now we are ready to move to another laboratory to see what they have prepared for us. Thank you very much. Hello.
Hello, dear colleagues. My name is Roman Morozov. I am a employee of South Ural State University, and the thesis of my scientific work is utilization of semiconductors as photocatalysts in different type of reactions. And here now I would like to show you how do we handle with organic pollutants in the wastewaters. Here we prepared solution, model solution of methylene blue dye, which is assumed as model wastewater solution. Put it in 2 glasses, and in the 1 glasses we put our material which we prepared for the remediation, this one. And this is blank solution which we would like to use for comparison of the activity. We would like to irradiate it with UV irradiation, and afterwards we will see how active it will be in degradation of this organic dye. So we have 2 similar irradiation sets, and now we put these glasses into it. And we begin to irradiate them with a UV spectra. So now we begin to count down to 15 minutes, and after this the reaction will be ended, and the solution should be transparent and white without any traces of the methylene blue dye. So now I would like to tell you about the principles of this phenomena. This phenomena is based on the photocatalytic effect, which occur when our material, that is semiconductor, absorbs UV light, and in its structure begins the separation of charges. Electron goes to the higher energy level, and another charge is hole, which has high oxidative power. So we prepared our materials from titanium dioxide, which is known to be one of the most popular photocatalysts. This compound is very abundant in nature. It's cheap enough, non-toxic, and so we use it widely for the remediation of waters and for different other reactions. In the South Ural State University Nanotechnology Center, we developed a new way of preparation of this material. As you know, titanium dioxide has some drawbacks in its application. Its most active allotrope modification, NTAS, is not stable, first of all, and another drawback is irregular shape. Here we developed a special way of preparation, which we call the peroxide road, which allow to prepare spherical shape particles with desired size which are desired to use in flow processes, and these particles are very useful to handle with. So the essence of this preparation way is utilization titanium peroxide complex as the precursor of titanium dioxide. Firstly, we prepare colloidal particles of titanium dioxide, then we dissolve them in hydrogen peroxide with formation of transparent orange or green, independence of pH value, solution of titanium peroxide complex. Then afterwards we can prepare our particles with desired size through different ways. We can precipitate our spherical particles by exchange of the solution. This phenomena occur because this complex is not stable in organic solvents, for example methanol, propanol, and so on. Or we can treat it hydrothermally, and as we know, this complex is not stable at high temperatures, at about 200 degrees. Afterwards, we can dope these titanium dioxide particles with, for example, silicon dioxide, which is known not very active in photocatalytic reactions, but in doping it may be helpful because of high adsorption capacity for the degrading matter, and so on. These materials were treated hydrothermally, and afterwards we prepared grains of few millimeter sizes, which are more useful in, for example, flow reactions or large-scale utilization, because they may be remediated or washed without a loss of them. The layout of this material, it looks like small particles, about 2 millimeter size. So time is going, and soon the reaction will be ended. So our results of our work were also used not only for the remediation of organic matter, but also we proceeded a few chemical reactions, reactions of organic synthesis, which are easily activated by the solar light. So this material can be also doped with other semiconductors, and all solar light may be used, and the spectra which is able to activate it may be widened. So now the time is going to its end, and now we can switch this one off, and so firstly we can see this material, which one is has no photocatalyst, and we can see that this material retains its color, blue color of methylene blue dye. So another glass contains the solution with our photocatalyst. As we can see, during this short time, methylene blue dye was completely degraded to water and carbon dioxide. This is a very effective process which gives us the opportunity to degrade not only methylene blue dye, but also very hazardous matter such as phenols and so on. So this is it. I would like to listen to your questions, dear colleagues.
Yes, we have several questions. Thank you very much. So the first one, first compliments on the great work. And what oxidant do you add to produce the hydroxyl radicals with titanium?
We did not use any special oxidant. We just used only UV irradiation, and through this process in the structure of our photocatalytic material, oxidant appears by itself. In our case, holes serves as oxidants.
Okay, thank you. A question from India, from Sonalika Agarwal. Is there any effect of different morphology of nanostructures on that?
Yes, sure. We developed the spherical particles of photocatalyst. As we know that this shape is very helpful for the flow processes, and nevertheless that we also developed the procedure how we can control the size of these particles by changing different organic solvents.
Thank you. The next one. Has your group already performed tests in a pilot reactor or similar?
In a pilot reactor, not yet, but we are going to prepare it. I think it will be done in the next year.
Thank you very much. The next one. What is the band gap of your semiconductor? And what type of semiconductor are you using? NPN or PNP?
We use titanium dioxide. Band gap is equals to 3.2 electron volts. And as it is titanium dioxide, it has a negative type of conductivity.
Thank you. Have you studied the oxygen defects in your material?
Oxygen defects, yes, we studied, we performed the XPS study of our materials, and we did not found a great amount of titanium in 3-valent state, and I think oxygen vacancies are not very abundant in it.
The next question is your semiconductor nano-sized?
Yes. First, the initial parts of our semiconductor has sizes which we can control from 100 nanometers up to 700 nanometers. And afterwards, we treat them to include into silicon matrix to prepare larger size grains, which will be more useful in flow process and in large-scale processes.
Thank you. Several more. Have you checked the reusability?
Yes, we did it. We checked the reusability of our semiconductors for their photocatalytic reactions in 5 cycles. And we found that it drops negligibly from 100% to 98% for in the reaction of methylene blue dye degradation. And we also used them for the adsorbents, and it performs well also.
Great, thank you. We have a question from Morena. Did you add any oxidizing or reducing agent again? And are you able to recycle your material?
In this reaction, we did not add any special oxidants or reducants. And yes, we checked 5 cycles of regeneration, recycled it, and it works well.
Great. A question from India, from Priya Yadav. Do you use any specific wavelength of UV light, or maybe any specific type of
Yes,
UV? Yep.
as it is titanium dioxide, it can be activated by UV light with a wavelength less than 400 nanometers.
All right. And any specific type of UV? UVA, UVB, UVC?
We can use mild UV spectra, UVA, beginning from 400 nanometers and less.
All right. And one more question. Do you characterize the possible byproducts of this reaction?
Yes, sure. For this reaction, it mainly degrades methylene blue dye to carbon dioxide and water because we checked it in the chromatograph, and this is it.
Thank you very much. It looks like we've run out of questions by now. Do you have any more remarks to make?
I would like to thank for attention all of the colleagues, and I would like to, if they want to cooperate with us, they can do it easily.
All right, thank you very much, Roman. Oh, actually, we have more questions. I'm sorry, if you are still here, we just received
Yes.
several more. Where are you currently collecting and storing the data for the various experiments that you perform? And do you have a specific instrument to collect and measure these data in real time?
For this device, we measure the UV absorption spectra on the spectrophotometer, and we have also a chromatograph, and all of these devices has very detailed made programs which allow to make with the data everything that we want to do.
All right. One more question from India, from Swati Singh. What was the titanium dioxide dose that you used during the experiment?
Yes, we used 100 milligrams of titanium dioxide per 25 milliliters of methylene blue solution.
And following that, is there any absorption on titanium dioxide?
Yes, this is a very good question. We checked the absorption experiment, but we did not find that it's active in this stage, because if you can see this material in the solution, you can find it it has white color, but if absorption phenomena occur, the color of the adsorbent would be blue.
All right, thank you very much. Yes, there are several remarks saying that it's a nice experiment. Yes, nice experiment and want to use it. Thank you very much.
Thank you.
Great. Well, it was very interesting, and I think everybody enjoyed the experiments just as much as we all did. And it looks like we have completed our program for today. And thank you very much. Tomorrow we will meet at regular time, as always, and we will have the results of the forum summarized. We will listen to the results of the contests. We will have some closing remarks from the heads of delegation. That's the plan for tomorrow. Thank you very much.
I wanna feel oppressed without any rest. I wanna see you sing, I wanna see you fight, 'cause you are the real beauty of human rights. Makes my body dance for ya. Makes my body dance for ya. Nobody can beat the Mama Africa. You follow the beat that she's gonna give ya. Only her smile can all make it go. The sufferation of 1,000 more. Makes my body dance for ya. Makes my body dance for ya. Makes my body dance for ya.